Shall we start? So just a small recap of what we have discussed yesterday. So we started with space technology, and in space technology we have seen definition of space technology. After that, what are the objectives of space exploration missions? Then we have seen organizational structure of ISRO, and under organizational structure of ISRO we have seen different centers. Similarly, what is antrics, what is NSAL. After that, we started seeing achievements of ISRO or in chronological order. Okay, what are the overall achievements? And till Mars orbiter mission or Mangalyaan mission we have seen. Okay, from there some more achievements we will see today. And once again recap of all the achievements. 1962 INCOSPAR was found. 63 first sounding rocket was launched from the Tumba Equatorial Launching Station. Then 1969 ISRO was found. 71 Satish Dhawan Space Center. Okay. 72 Space Commission and Department of Space. Both were formed and ISRO was brought under the control of Department of Space. Then 1975 Aryabhatta first satellite was launched. 1980 SLV-3 first launch vehicle of India was successfully tested. Then 1984 Rakesh Sharma was sent into space, first Indian to go into space. After that, in 1992 ASLV, 94 PSLV, and 99 PSLV started foreign operations. Then 2001 GSLV, and 2008 Chandrayaan 1. After that, 2013 IRNSS, Indian Satellite Navigation System, and 2014 Mars orbiter mission. Till there we have seen. And I think I have given you one question. Sara? Yes. Okay. After the class, okay, I will check it. Right. So after 2014, I already told you GSLV Mark III, okay, started its operations much later. By then, from 2014, GSLV Mark II started its operation. Okay. Later in 2016, another launch vehicle called RLV-TD was successfully flight tested. Here RLV means reusable launch vehicle. Normally what happens when we launch a rocket or a launch vehicle, it will go into space. Okay, any parts, okay, they will come apart and again it will fall into Bay of Bengal or they will just evaporate in the atmosphere itself. That means once we use a launch vehicle, again we can't reuse it. But very recently the technology is being tested so that at least the first stage or the second stage of the launch vehicle, if you can again retreat it back, then what will happen? We can save a lot of money simply. At least one stage of the launch vehicle after going into space, if it can come back to the same launch station, okay, we'll be able to save a lot of money. And right now such a technology is there only with the SpaceX. Okay, SpaceX Falcon. Okay, Falcon is the launch vehicle that is used by SpaceX, and only SpaceX Falcon has such a capacity of reusable launch vehicle. India is also testing for that. As of now, we don't have. That's why we said TD here means technology demonstrator. That means we are still testing the technologies that we might use in the future for a reusable launch vehicle. Okay. After that, from 2017, our GSLV Mark III started its operation. Okay. And similarly, later, much later, in 2018, Chandrayaan 2 was launched. Okay. 2019, Chandrayaan 2 moon mission was launched. And 2020, IRNSS or NAVIC that we have already sent into space got International Maritime Organization recognition. IMO recognition. So we were only the fourth satellite navigation system that got this recognition. Okay. And what are the other navigation satellite systems and all, we will see. Okay. Apart from India's NAVIC or IRNSS, what are the other navigation satellite systems of the world? All those things we will see. So here, 2016 RLV-TD was flight tested. 2019 Chandrayaan 2 was launched. and 2020 our Navy got IMO recognition. Now I already told you Chandrayaan 1 and Mangalyaan mission, they were launched by using our TSLV, because till then GSLV didn't start its operation. But 2019 Chandrayaan 2 was launched by using GSLV. Okay, this is by using GSLV Mark 3. Again Chandrayaan 3 also same, GSLV Mark 3, or generally what we call as LVM 3. Okay, sometimes it is called as. Next, later from January 2020, we know that because of COVID, not many important operations happened till Chandrayaan 3. Chandrayaan 3 varaku, not too much important operations. Later, much later, in 2023, Chandrayaan 3 was launched. Okay, and here it is saying LVM 3. LVM 3 is nothing but GSLV Mark 3. Launch Vehicle Mark 3 we call it. Okay, GSLV Mark 3. Chandrayaan 3 mission, and after that on September 2nd, Aditya L1 mission. Okay, Aditya L1 mission on September 2nd, again last year 2023. This year in January, okay, 2024 January, we have sent a mission called ExpoSat. ExpoSat mission 2024. Again, one more important satellite system. Again, don't worry, all these will come later. We will learn in detail about them. So this year in 2024, one important one, ExpoSat mission, and in August 16, 2024, we have successfully flight tested SLV. Okay, SLV D3 we call it, or Demonstrator 3. SLV D3 was successfully flight tested with the third successful flight testing of SSLV, okay, small satellite launch vehicle. Right now we have successfully tested the technology that is related to small satellite launch vehicle. So now what we are going to do, as I have told you in the last class, is ISRO going to manufacture SSLVs? No. SSLV technology will be transferred to the private sector. And here the role of NSIL will be important. By using NSIL as a mediator, we are going to do the technology transfer of this small satellite launch vehicle, so that by using the technology, some of the private players that are in the market with respect to space technology, they can develop these small satellite launch vehicles, and they will be giving those small satellite launch vehicles to either ISRO, or they can launch their satellite launch vehicles on their own. So simply they can say that we are going to launch a small satellite launch vehicle. If anybody wants to send their satellite, please pre-order. So when some private companies wants to send their satellites into space, okay, they will ask for small any company, let us say Agnikul Cosmos, they have told that next year we are going to launch a SSLV, our Agniban rocket. So if anybody is interested to send their satellites to space, please pre-order. So some private companies who wants to send their own satellites, okay, they will pre-order with Agniban or Agnikul Cosmos, and when sufficient number of satellites number is reached, that is the payload capacity of that, then those satellites will be launched by using that SSLV. Is there any role of ISRO here? Nothing. Okay, there won't be any role of ISRO, because the satellite launch vehicle is manufactured by a private company. They are going to have their own launch pad, either at Sriharikota, or we are constructing a new space station in Kulasekarapatnam. Again, all these things we will see. There, either they will have their own launch pad, and using their own launch pad, they will launch their own launch vehicle with some private satellites. Okay, and they will also manage those satellites as well. So in future, what is going to happen is end-to-end operations of space explorations in India is going to be done by the private sector. And that is the main objective of our space policy, which came last year, 2023. Okay, a new space policy was released by the government. In that it is saying that the role of private sector is going to increase. Alright. So this is with respect to overall timeline. So by now, we know what we are going to discuss, okay, in the space technology. Okay, we have seen different space missions, different launch vehicles, when they were launched, etc., etc. So this is overall chronology or achievements. So questions will be asked on this in prelims. Okay, in chronological order, arrange the following important events. Like that, questions will be asked. Sometimes what UPSC will do is they will mix and match up with multiple subjects. They will give one event from science and technology. They might give one event from history, another event with respect to economy, like nationalization of banks, etc. Okay, like that, from multiple subjects, multiple events can be asked, and UPSC can ask us to arrange them in a chronological order. Chronology means first what happened, after that what followed. That is what is chronology. Okay. So either you remember the years or not, it doesn't matter, but at least you need to remember the chronological order. Okay. Next topic, orbits. Now we are saying that we have different types of satellites, like remote sensing satellite, we have navigation satellites, we have communication satellites. These are the words we have already seen. Now, for placing these satellites, we will require some kind of orbit. Normally, what happens in the universe? There is sun, and around the sun, planets are revolving. Now, satellites, what they will do? Around the earth, they have to orbit. Right? Now, around the earth, if they have to orbit, what are the different kinds of orbits we have? And in each kind of orbit, what are the different types of satellites we place? We don't place all the types of satellites in a particular orbit. Okay? Different types of orbits we have. In different types of orbits, we place different types of satellites. Now, what are those orbits? And in each orbit, what are the different types of satellites that we place? We'll see. So first, mainly we have three types of orbits. Low Earth orbit, medium Earth orbit, and high Earth orbit. Okay? Simple. So, from the Earth surface, okay, let us say this is the Earth surface. From the Earth surface, based on what is the distance, okay, at what distance we are going to place our satellite so that it is going to orbit the Earth. That is what is called as a orbit. Okay, based on the distance, we'll classify them as low Earth, medium Earth, or higher. Generally, low Earth orbit means from 180 to 2000 kilometers. Alright, 180 to 2000 kilometers, it is called as low Earth orbit. Next, medium Earth orbit means from 2000 to 35,786 kilometers. 2000 to 35,786 kilometer. High Earth orbit more than or equal to 35,786 kilometers. Now, we could have used something like low Earth orbit, we are saying 180 to 2000. Fine. For medium Earth orbit, can I say something like 2000 to 30,000? Why I am using specifically a number like 35,786? I can say 35,000 or I can say 36,000. Instead of using a rounded off number, I am using a particular number like 35,786. Why is that so? Okay. Yeah? No. See, here we are saying from the surface of the Earth, at what distance we are placing the satellite. Now, let us say this is the surface of the Earth. Low Earth orbit will be somewhere here. That means from 180 to 2000 kilometers. From there, way back, 35,786 kilometer in between medium Earth orbit. From 35,786 and beyond, high Earth orbit. Okay. Now, why this 35,786? For understanding that, let us watch a video. Okay.
In this video, we shall look at the difference between geosynchronous orbits, geostationary orbits, and polar orbits. These terms appear often when we study science and tech current affairs for UPSC prelims. In this video, we briefly explain these terms with the help of 3D animation. Man-made satellites orbit around Earth. If it is far away from Earth, satellite takes more than 1 day to complete its orbit around Earth. Earth takes 23 hours, 56 minutes and 4 seconds to complete one rotation, almost 24 hours. This is called 1 day. If a satellite that orbits Earth is far away, it has to travel longer paths to complete one orbit around Earth. To complete one revolution around Earth, it may take 2 or 3 days or even more, depending on how far it is from Earth. If it is near to Earth, it orbits faster and takes less time for revolution. If satellite is very close to Earth, it orbits Earth 15 to 20 times just in a day. When this distance is 35,786 kilometers from Earth, satellite takes 24 hours to complete one orbit around Earth. This is same as Earth's rotation period. So, for someone looking above from ground, this satellite appears to be stationary because both are moving at same speed. If distance is more than 35,786 kilometers, satellite takes more than 24 hours to complete one orbit. If it is closer than 35,786 kilometers, it orbits faster than Earth. International Space Station, which is at a distance of around 400 kilometers from Earth's surface, orbits Earth nearly 15 times a day. Now let us study geostationary satellite orbit. It is at a distance of 35,786 kilometers from Earth's surface. At this distance, satellite takes 24 hours to complete one orbit, same as Earth. To be precise, it is
First, why 35,786 kilometer? Understood? So normally, when a satellite orbits around the Earth below 35,786 kilometer, okay, it is going to orbit there more than one time in a day. If it is very near to the Earth surface, let us say in the low Earth orbit, like for example in the video they have told you about International Space Station, okay, which is placed around 450 kilometers above the Earth surface. Okay, it is placed at a kilometer 450. So International Space Station orbits around the Earth almost 15 times a day. Because the orbit is placed very near to the Earth, okay, it can orbit around the Earth more than one time in a day. Now at a particular point, 35,786 kilometer, a sweet spot will enter where the satellite's revolutionary speed will be equal to the Earth's rotational speed. Okay, Earth rotate on its own axis, because of that day and night gets created. Okay, ఒక rotation కి Earth కి ఎంత టైం పడుతుంది? 24 hours. So Earth is rotating at a particular speed and the satellite is going to orbit or revolve around there at a particular speed. At 35,786 kilometer, they will match their speeds and they will be in sync with each other. So that's why 35,786 kilometer, that orbit, we call it geosynchronous orbit. That means it is in sync with the Earth's rotation. So beyond 35,786 kilometer, if we place a satellite, it will take more than one day to revolve around the Earth. Below 35,786 kilometer, okay, it will revolve around the Earth more than one time. Understood? At that particular point, it will take just 24 hours to orbit around the Earth. That means it is going to be in sync with the Earth's rotational time period. That's why the kilometers 35,786. Okay. Now in the video, we are going to see what are the differences between geostationary orbit and geosynchronous orbit. Okay.
It's 23 hours, 56 minutes and 4 seconds. But consider it as 24 hours for the sake of simplicity. From the ground, it appears to be stationary at a point in the sky. This is important for communication purposes. Antenna on the ground always has a direct communication link to the satellite. There is no need to change the direction of antenna continuously. This orbit lies directly above the equator and at a distance of 35,786 kilometers from Earth's surface. This is called geostationary orbit. Satellites that orbit in this orbit are called geostationary satellites. Let us now study geosynchronous orbits. Geosynchronous orbits are also very similar to geostationary orbits, but there is one difference. Geostationary orbit is above the equator of Earth, but geosynchronous orbit need not be exactly above equator. It often orbits at an inclination. The satellites in this orbit also take 24 hours for one revolution, but it is not above the equator. Since this orbit is at an inclination, for someone observing from ground, satellites appear to be moving north and south in the sky in a day. But the satellite will be at the same place in the sky next day at the same time. For example, if a satellite moves 25 degrees north and south in a day, it will be at 10 degrees north at 3 p.m. every day. Hence, in geosynchronous orbit, the satellites return to same place at a particular time of the day. Antennas that receive communication from geosynchronous satellites are capable of north-south movement to receive signal. Although geosynchronous satellites move north and south, it broadly remains at the same observable place in the sky. Keep in mind, geostationary orbit is also a type of geosynchronous orbit. Speciality of geostationary orbit is that it is above equator. All geostationary orbits are geosynchronous orbits, but not all geosynchronous orbits are geostationary. Next, we shall see what are polar orbits. Satellites in polar orbit pass through north and south poles of Earth or near to it. Polar orbit satellites are very close to Earth in the range of just 200 to 1000 kilometers. Hence, it orbits Earth 15 to 20 times a day. For example, a polar satellite that orbits around Earth at around 700 kilometers orbits Earth nearly 14 times in a day. Since these are very close, it can be used for mapping Earth, forest mapping, weather forecasting, observing Earth for military purposes, etc. It orbits Earth 14 times a day or more. It passes through an area several times in a day. Hence, repeated images of same place in short time intervals can be taken. By using 2-3 satellites, a particular Earth strip can be observed continuously in a more detailed manner. Let us now look at another additional information that is useful. Low Earth orbit is for the space below 2000 km from Earth's surface. Medium Earth orbit from 2000 km to 35,786 km. That is geosynchronous orbit, and orbits above this are called high Earth orbits. Thank you for watching.
So, in the video, they have explained what is the difference between a geosynchronous orbit and geostationary orbit. What you have understood? What is the main difference between them? Right. Both the orbits are at a distance of 35,786 km. Any orbit at a distance of 35,786 km, we call it geosynchronous orbit. Why? Because the rotation of the satellite will be in sync with the Earth's rotational time period. But there will be only one geostationary orbit. That is again at a distance of 35,786 km, but in plane with the equator or above the equator. There is only one equator. So above the equator, we can only have one orbit at a distance of 35,786 km. That orbit we call it as geostationary orbit. Now, why the name geostationary? Okay, so from the Earth, when we observe the satellite from the Earth, we will feel like it is not moving at all. It is just stationary. So, because Earth is rotating, satellite is revolving. Both are in sync with each other. So when we observe from there, we will feel like that satellite is not moving. It is just stationary there. Whereas geosynchronous orbit, even though it is at a distance of 37,786 km, when we observe from there, it will be something like this. It will be in sync with the Earth's rotation, but only difference will be, it will be moving in a north-south direction. Understood? It will be in the same longitude. And it will be in sync with the Earth. But geostationary, it is not moving at all when compared to the position from there. Whereas geosynchronous satellite, it will be just moving in a north-south direction, but in the same line. That is the only difference. So there is only one geostationary orbit. The name is coming because when we observe from the Earth's surface, we will feel like the satellite is stationary. Okay, whereas geosynchronous, from where the name came, the satellite will be in sync with the Earth's rotational time period. Okay, at that particular point. All right. Now, as we have already discussed, medium Earth orbit, low Earth orbit, high Earth orbit. Now, two more terms: escape velocity and orbital velocity. What do you think is the difference? Now, let us assume we have thrown some object from the Earth. What will happen? Okay, it will go to some distance, there will be some kind of projectile, and it will again fall on the Earth only. Similarly, if we throw it with a little bit more speed, it might fall far away from there, but still it will fall on there because of gravity. Okay, it's a gravitational force. But there will be a particular velocity at which, if we launch a particular object into the space, okay, it will not fall on the Earth. Instead, okay, it will orbit around the Earth. At a particular velocity, when we launch an object, instead of falling on the Earth, okay, it will orbit around the Earth. So the minimum velocity that is required for an object to orbit around the Earth is called orbital velocity. Instead of falling on the Earth, the minimum velocity that we should give to an object so that it won't fall, but it will orbit around the Earth. That is what is called as orbital velocity. Write the definition. Orbital velocity. Orbital velocity. The minimum velocity. The minimum velocity at which we should launch a object into the space. We should launch a object into the space so that it will not fall back. So that it will not fall back onto the Earth's surface. And instead orbits around the Earth. So, how a particular satellite or object orbits around the Earth? Okay, the explanation will be very simple. Okay. Let us say this is Earth, and we have launched a particular object with orbital velocity. Okay, what we will do? We will use a launch vehicle. In a launch vehicle, we will take the particular satellite to a particular distance. Wherever we want to launch it, to that particular distance, we will take that, and from there, with a particular velocity, we will release it. Okay, if it is very near to the Earth's surface, the velocity that we should give should be more. Why? Because near to the Earth's surface, the gravitational pull of the Earth will be very high. So, at a particular velocity, when we launch that object, what will happen? It will also face the Earth's gravitational force. There is, okay, forward moving velocity. There is another velocity, okay, or gravitational pull of the Earth. Both of them will act together and it will keep the object in that orbit. Forward velocity in a straight line. Gravitational pull of the Earth in another direction. Both of them will be acting at the same time so that the object will be in that particular orbit. Zaina? Forward velocity alage Earth yokka gravitational pull rendu kalisi ఆ ఆబ్జెక్ట్ ని ఎర్త్ చుట్టూ తిరిగేలాగా చేస్తాయి. That is why an object will stay in the space orbiting around the Earth. Okay, if you don't give the particular velocity, what will happen? It will again fall back on the Earth. If a particular object or a satellite is near to the Earth, because the gravitational pull will be very high, the velocity that we should give to that particular satellite should be a little bit higher. When compared to somewhere in the geosynchronous orbit, no need to give too much velocity because the Earth's gravitational pull at that distance will be comparatively less. Now, what is escape velocity? Escape velocity is a velocity, okay, where the object that we are going to send into the space should escape from the total gravitational pull of the Earth. Instead of orbiting around there, it should just go away from the Earth's surface into the outer space. Okay, so escape velocity will be what? Right? Definition of escape velocity. It is the minimum velocity. It is the minimum velocity at which an object has to be launched into the space. An object has to be launched into the space so that it will escape Earth's gravitational pull. Launched into the space so that it will escape Earth's gravitational pull and will enter the outer space. Earth's gravitational pull and will enter the outer space. Alright. So beyond the Earth's gravitational pull, okay, why we want to send such a object like that? If you want to explore something like Mars, okay, if you want to explore Mars, the object has to escape from the Earth's gravitational field and has to go to the Mars. So for such a type of satellite, we need to have something called escape velocity initially, so that first it will escape from the Earth's gravitational pull and then it will go towards the particular planet, either Mars, Venus or any other planet, wherever we want to send it, or some asteroid. Yesterday I have told you one mission of NASA, OSIRIS-REx. It is to study a particular asteroid called Bennu. So for that we will require, for outer space exploration, escape velocity. Orbital velocity is what? The minimum velocity that will be required for an object to orbit around the Earth instead of falling back onto the Earth's surface. Okay. Now we have discussed three types of orbits, mainly low Earth, medium Earth and high Earth. And apart from that, we have also seen the difference between geosynchronous and geostationary. Okay. All the matter regarding to that now we will see. So first, low Earth orbit. So as the name suggests, the orbits are relatively closer to the Earth. So the satellites that are launched at a altitude, not 2000 kilometer, and could be as low as 160 or 180, somewhere around. So below 2000 kilometers. And close proximity to the Earth makes them useful for multiple applications, especially what? Remote sensing satellites. Low Earth orbit is mainly used for remote sensing satellites, or what we call as Earth imaging. Okay, low Earth orbit, just remember, used for remote sensing or Earth imaging satellites. Remote sensing or Earth imaging satellites. Why we have to place remote sensing or Earth imaging satellites in low Earth orbit? Because we have high resolution. If we place them far away from there, the camera that we used to observe, okay, may not observe, okay, with very high resolution. If we place them near to the Earth's surface, okay, from a particular orbit, it will be looking at a particular location in a clear manner. Okay, so that's why we place remote sensing or Earth imaging satellites in the low Earth orbit. But apart from that, mainly we use it for remote sensing satellites or Earth imaging. But there is one satellite system which is actually a communication satellite system. And in the video also they have mentioned it. Generally, geostationary orbit is the orbit which is used for placing communication satellites. చూసారు కదా? But okay, SpaceX one satellite system called Starlink project. There is a project called Starlink project of SpaceX, okay, which they have started very recently. Recently means just in the last 10 years, where they want to place thousands of communication satellites in the low Earth orbit, and by using these communication satellites, they want to provide satellite-based internet service. Normally, when we use internet, okay, it will come from two sources. One, directly from our mobile data, which uses mobile signals from a particular tower that is near to us. Another way that we use internet is from Wi-Fi or broadband. Okay, broadband service. Now, in both these services, there is one inherent problem. Especially Wi-Fi, when we are using Wi-Fi, if there is a power cut, can we use it? No. Similarly, if we are using mobile internet, if there is no signal, then can we use the mobile data or internet? Again, no. But if I am going to provide you internet by using a satellite that is there in the space, which covers a particular area, you will get internet wherever you are, whether you are in a deep forest, or whether you are on a mountain top, or whether you are in your village, or whether you are in your bathroom. Ekkadaina signal vastadi. Satellite based internet service is going to be provided by Starlink project of SpaceX. And by using this Starlink project, actually what they have done is they have provided first ever time, okay, internet services for Amazon tribal people. You might have heard about Amazon forests. Okay, where they are located? South America. In South America, near Brazil and all, we'll have Amazon forest, one of the largest equatorial forests in the world. So, deep inside Amazon forest, for particular tribal people, okay, Starlink project has provided with internet services. Okay, they have provided them with some mobiles free of cost with internet facilities. Okay, so now with this Starlink project, what they want to achieve is throughout the world, throughout the globe, they want to have a global coverage of internet by using satellite based communication. And very recently, during the Russia-Ukraine war, okay, the Starlink project has helped Ukraine a lot. How? What Russia was doing? Yes.
Because of IT company, use Starlink satellites.
Yes. So what Russia has done is, when they have started the war, they have destroyed all the communication facilities of Ukraine. Communication centers ఏదైతే ఉంటాయో ఉక్రెయిన్ లో దాన్ని ముందే డిస్ట్రాయ్ చేస్తారు. దానివల్ల ఏమవుతుంది? The soldiers cannot coordinate with each other without any kind of communication facility. But they have made use of Starlink project satellite system and they have made the communication. So already Starlink project, it has shown some of its application. But again, from that what we can understand, tomorrow it can be used against a particular country as well. It can be against the privacy of a particular individual as well. Because everywhere if the coverage is present, okay, they can weaponize that as well tomorrow. Okay, so some issues are also there, but what is the Starlink project? Satellite based communication facility. Instead of placing the satellites in geostationary orbit, they are going to place the satellites in low Earth orbit. Now, why generally we place satellites in geostationary? That also we need to know. Okay. Let us say again, this is Earth surface. If you place a satellite in low Earth orbit, somewhere at a distance of 400 or 500 kilometers, the coverage of this particular satellite will be only for a small area on the Earth surface. Okay, it will only cover small area. Like in the video also they have shown polar orbits. Polar orbit is nothing but low Earth orbit only. Okay, how much coverage is there for that satellite? Only particular strip of the Earth. అంతే కదా. బట్ వెన్ we place a satellite in geostationary orbit, okay, it is going to cover almost half of the earth. A single satellite can cover almost half of the earth. That means just by using 2 geostationary satellites we can provide communication for almost the whole earth. That's why majority of the communication satellites are placed in geostationary orbit, because we require less number of satellites. But when we place the communication satellites in low Earth orbit, we might require thousands of satellites to provide the communication, because they will cover only small part of the earth, only a strip of the earth. Okay, that is one problem. Another problem, okay, when it comes to geostationary orbit, it is far away from the earth. So a particular signal to go to the satellite and again come back to the earth, it will take a lot of time, and this is what we call as latency. Okay, the time taken for a signal to go back to the satellite, okay, to reach the satellite and again come back, the time taken we call it latency. Now if we have less latency, automatically what will happen? The speed of the service will be faster. అంతేనా? లేటెన్సీ పెరిగే కొద్దీ మనకి స్పీడ్ ఏమవుతుంది? తగ్గుతుంది, because the distance covered is more. Okay, so if we place a particular satellite in low Earth orbit, here the latency is very less. So with less latency we can provide the particular service in a faster manner. So the advantage of Starlink project will be what? They are going to provide us satellite based communication facilities at a very high speed. Okay, because they are placed in low Earth orbit. All right. So Starlink project, 895 communication satellites are in the orbit out of the 995 launched by SpaceX recently, and in total they want to place around 12,000 satellites to be deployed with a possible extension up to 42,000 satellites. Too much number. Okay, very high number. Communication satellites are being launched into low Earth orbit, and the reason is to reduce latency. Okay, one reason to reduce latency. Another reason, at the end of the day there is only one geostationary orbit which has to be used by all the countries. So just a private organization like Starlink, they cannot place multiple satellites in geostationary orbit because it will not be viable. That's why they are making use of low Earth orbit by placing multiple satellites, thousands of satellites in low Earth orbit, and one advantage will be reduced latency, and because of that high speed. Okay, so normally communication satellites are placed in the geostationary orbit, but one exception, Starlink project, they are placing communication satellites in the low Earth orbit. All right, and other than that,
Sir, it is not a threat to biodiversity. Like stars.
no, it is a satellite, right? It will be placed around 400 kilometers above the Earth's surface. Our atmosphere will be till only 100 kilometers. You are asking with respect to signals. No, satellite signal will not harm much. Okay. Next, all the Earth observation satellites and spy satellites are launched into the low Earth orbit because they have to observe the Earth from a particular orbit. Spy satellite also what it will do? It has to observe the either borders or a particular country or anything like that. So for observation we will require a satellite near to the Earth's surface. So that's why they will be placed in low Earth orbit, as they could watch the surface more clearly with great resolution. And we have already seen in the video, International Space Station is placed at about 400 kilometers above the Earth's surface, and we have already seen in the video that it will revolve around the Earth almost 15 times in a day, because it is near to the Earth. At 35,786 kilometers, one revolution. If it comes near to the Earth, more revolution. If it is in low Earth orbit, 14 to 15 times a day, it is going to revolve. And Hubble telescope, another important telescope, It was placed approximately at a distance of 540 kilometers. Okay, again, Hubble telescope, International Space Station, in detail we will see later. Okay, about them, because those are important topics, we'll see. So right now we have seen only the low Earth orbit. Low Earth orbit is mainly used for what? Placing Earth observation or remote sensing satellites. One exception, Starlink project, where they are placing communication satellites in the low Earth orbit. Alright. Next, medium Earth orbit. Medium Earth orbit is mainly used for navigational satellites. What are navigational satellites? These are the satellites that will provide us with three services called positioning, navigation and timing, or what we call as P&T services. Navigation satellites will provide us with P&T. Now what is this positioning, navigation and timing? Now just imagine you have opened your Google Maps. First what it will show? Google Maps open cheyangane first em chupistadi? Where you are located. What is your position? That is what is positioning. Later you will ask you want to go to a particular location. Then what it will show you? Navigation. That means the directions for that location. And it will also show you along with navigation how much time it will take for you to reach that particular location. That is what is timing. P&T service. These are the services provided by navigation satellite systems. And navigation satellite systems are generally placed in medium Earth orbit. But again, one exception is India's navigation satellite system, which is placed in geosynchronous and geostationary orbit. Okay, in our Indian regional navigation satellite system or NAVIC, okay, there are 7 satellites, out of which, okay, 3 of them are placed in geostationary orbit, 4 of them are placed in geosynchronous orbit. But rest of the country's navigation satellites are generally placed in medium Earth orbit. Now, what are the different types of navigation satellite systems that are there in the world of different countries? So, list of global navigation satellite system, very important. Already a previous year question was asked in the year 2023. Just 2 years back in prelims, a question was asked. So the question was something like this: which of the following countries has their own navigation satellite system? So ఇంతకీ ఏ కంట్రీలకి navigation satellite system ఉంది? That we need to know. So first, GPS. Okay, GPS ఎవరిది? US. Okay, no need to know the full forms. Even if you remember the shortcuts, that will be fine. Only India's we need to know the full form. Okay, next, Baidu or BDS, China; Galileo, Europe; GLONASS, Russia; okay, IRNSS or NAVIC, India; QZSS, Quasi Zenith Satellite System, Japan. And we need to by heart them. Already question was asked, and again in multiple exams, generally match the following type questions can be asked. Okay, they will give you on one side navigation satellite system and they will ask you to match with the countries. So GPS, America; Baidu or BDS, China; Galileo, Europe or European Union we can say. Okay, similarly GLONASS, Russia; IRNSS or NAVIC, India; QZSS, Quasi Zenith Satellite System, Japan. Okay, you have to by heart. Just write them down in shortcuts. No need to know the full forms and all. And generally, if you are going to buy a new mobile today, okay, there in the instructions in the navigation system, they will show you it is pre-installed with GPS, Galileo, GLONASS and IRNSS. Okay, today all the mobiles are using 4 navigation satellite systems for their operation. right? So next one, high Earth orbit. In high Earth orbit, we'll have again two types of orbits, geosynchronous and geostationary. Right. High Earth orbit. As we have already seen, when a satellite reaches 35,786 kilometers from the Earth's surface, at that particular point, it enters into a sweet spot where the satellite's revolutionary time period equals the Earth's rotational time period. Okay, so that's why we call it, it is in sync with the Earth. Geo means what? Earth. Geosynchronous means in sync with the Earth. Okay, so and since the satellite is synchronized with the Earth's rotation, it stays over the same longitude even though it may drift from north to south. As I have already told you, in geosynchronous, when we observe from there, we will feel like it is in the same longitude, but it is moving from north to south direction. Whereas if it is in geostationary, then we will feel like it is not moving at all. Okay, that's why geostationary. So this type of orbit we call as geosynchronous orbit. But the satellite in the geosynchronous orbit, if it is in plane of an equator, either we call it in plane of an equator or above the equator, okay, which does not move a little, okay, relative to the position on there, then we call it geostationary orbit. And as the name suggests, there is little difference between the two types. What is the difference? Geostationary, it will stay at the same point and it will not move at all when we observe from there. Geosynchronous, at the same distance, 35,786 kilometers only, but we will feel like the object is moving in a longitude in the north-south direction. Okay. Again, by making use of this diagram, we will try to understand. At 35,786 kilometers, we can have hundreds and thousands of orbits. Let us say this is one orbit, the distance from the Earth's surface 35,786. I will draw another orbit something like this. Again the distance is 35,786. One more orbit 35,786. Like that we can have multiple orbits at a distance of 35,786. But there is only one orbit which is in plane with the equator at a distance of 35,786. That is what we are calling as geostationary. We can have thousands of geosynchronous orbits, but only one geostationary orbit at a distance of 35,786, which is in plane with the equator or above the equator. Okay. So the difference between them, when we observe from there, if the object we feel like it is stationary, not moving at all, that is geostationary orbit. If it is in the same longitude but moving in north-south direction, then it is geosynchronous orbit. Both at a distance of 35,786. Okay, this diagram is for your understanding. Science and technology, we require a little bit of imagination. Then only we will understand few concepts. And without slides, we cannot teach. Any board by nesi me imagine chesukonte kashtam kada. Next, one more orbit called geotransfer orbit. Normally we are saying at 35,786 kilometers we have a satellite and we are calling it geostationary satellite or the orbit geostationary orbit. Now, whatever the launch vehicles that we have, do you think they can travel to 35,786 kilometers and can place a satellite there? అంటే అంత దూరం 35,786 kilometers ట్రావెల్ చేసి అక్కడికి వెళ్ళి ఆర్బిట్లో శాటిలైట్ ప్లేస్ చేయగలవు అని అనుకుంటున్నారా? యాక్చువల్లీ దట్ ఈస్ నాట్ పాసిబుల్. ఓకే, నార్మల్లీ అవర్ లాంచ్ వెహికల్స్ ఆర్ రాకెట్స్. Rockets are launch vehicles. they can only travel up to certain distance only. If it is low Earth orbit, they can directly place the satellite there. But if it is geosynchronous orbit or geostationary orbit, we make use of something called geotransfer orbit. So simply, the launch vehicle will move in this yellow line. Okay, it will go and place the satellite here, and initially the satellite will follow the path of this blue line. Finally, when it reaches the 35,076 kilometer, then it will attain that orbit. Okay, again for imagining that, let us look at one animation related to this. So from here, first it will follow the blue line. Okay, that blue line is what we call as geotransfer orbit. For transferring the satellite to the geosynchronous orbit, we will use an in-between orbit called geotransfer orbit. Okay, so geotransfer orbit is an elliptical orbit used to transfer a spacecraft from a low altitude orbit or flight trajectory to geostationary or geosynchronous orbit. Okay, write this. Next topic, geostationary orbital crowding. Now, as we already discussed, there is only one geostationary orbit, and that one geostationary orbit has to be used for placing communication satellites of multiple countries. So automatically what will happen? There will be some kind of more demand than whatever the space that is available. Okay, let us imagine something like this. Let us say this is geostationary orbit, and on this geostationary orbit there are particular parking spots available for placing the satellites. We cannot place two satellites very near to each other because they might collide. So at a particular distance we have to place the satellites in geostationary orbit. Let us say like that, overall in the orbit some approximately, not the exact number, 1000 parking spots are available. Let us imagine. But let us assume there is demand for communication satellites more than 1000. In such a situation, what do we call it? More demand, less parking spots. That is the situation we call as geostationary orbital crowding. Too much crowding is there in the geostationary orbit, and right now if another country wants to send their communication satellite, a parking spot may not be available. Okay, and normally who is going to allocate these spots or parking spots for the satellites in the geostationary orbit? For that we have an organization, International Telecommunication Union, okay, which works under United Nations. Okay, ITU or International Telecommunication Union grants the operator exclusive rights to use the slot that is there in the geostationary orbit approximately for 15 years. And is there any criteria for allocating this? No. On a first come first serve basis. Whoever applies for the slot on a first come first serve basis, they will get that slot. So because of this, what is happening? There is some kind of inequality. Because right now, countries like India, US, Russia, etc. have the capability to send their satellites to geostationary orbit. Whereas some other countries like African countries, they may not have even launch vehicle technology. So they cannot have capabilities to send a communication satellite. They don't have the capability to even make a communication satellite. They are just making use of other countries' communication satellite. So because just they don't have the capability, they are not going to have any slots in the geostationary orbit. Let us assume tomorrow they actually get the capability to manufacture a communication satellite or to send a communication satellite to geostationary orbit. What will happen? There won't be any parking spot available. Okay, so there is some kind of inequality as well, but there is no solution right now. Okay, because we have only one geostationary orbit. So since there is only one geostationary orbit, the number of satellites that could be launched in that orbit are limited, and the telecom operators are having difficulty to find the parking spots to launch the satellites into geostationary orbit. And that situation is what we call as geostationary orbital crowding. Okay, as the satellites must be placed at a distance avoiding the collision and interference, ITU, International Telecommunication Union, grants the exclusive slot for around 15 years on a first come first served basis. Okay, and a finite number of slots is making telecom operators stack as many antennas as possible into a single satellite. Now, can there be any other solution for this geostationary orbital crowding? Problem ఉంది. Problem ఉన్నప్పుడు దానికి solutions కూడా ఏదో ఒకటి ఉండాలి కదా. Now, can you tell me any solution that you can think of for this geostationary orbital crowding? Any solution that you can think of? Anything, whatever comes to your mind.
ఈ satellites కనుక ఎక్కువ పంపించుకోవడానికి లిమిట్ పెట్టి
బట్ స్టిల్ అప్పుడైనా సరే మనకి అట్ ద ఎండ్ ఆఫ్ ద డే పార్కింగ్ స్పాట్స్ ఆర్ లిమిటెడ్. అదర్ దాన్ దట్ లిమిట్ పెట్టడం కాకుండా దీనికి ఏదైనా ఆల్టర్నేటివ్ ఉందా అంటున్నాను. ఎనీ ఆల్టర్నేటివ్? Distribution of okay, I am not talking about the inequality. Overall, the problem of geostationary orbital crowding, can we solve it in any way? Is there any alternative for this? That's my question. Connecting satellites, yes, that can be one solution, so that we can make use of full scale of the geostationary orbit. I will explain that, don't worry. Yeah, any other? Yes, we can use low Earth orbit maybe, or medium Earth orbit to place a communication satellite. But yes, there will be some problem because it may not have the coverage just like a geostationary orbit. But still, as Starlink is doing or SpaceX is doing in the Starlink project, we can place them in low Earth orbit. That can be one solution. What else? Expand? Ela? Then we have to become God. Okay. That cannot be expanded. The orbit is orbit. Ante. At a distance of 35,786. Yes. Any other solution? Right. We will see some of the solutions for geostationary orbital crowding. So, increase the satellite capability and utilization. So, normally whatever is the satellite capability right now, increase its efficiency more, so that more number of satellites may not be required. A single satellite should have the capability of 2 to 3 satellites. Okay, make it more efficient. So, increase the capability and utilization of already placed satellites. That is one solution. And use non-geostationary communication satellites. That means use other orbits like low Earth orbit. Okay, just like SpaceX is doing for the Starlink project. And one more, use more frequencies, use more transponders, use more frequencies for the communication satellite, and use inter-satellite link and formation of satellite cluster. These 2 points are a little bit similar to each other. Let us try to understand. Now let us say we have 3 satellites here. First solution we are saying use inter-satellite link. That means link all the 3 satellites and make it a single satellite. Why we need to do that? Let us say this is a satellite of a particular country, US anukundam. Okay, ఇది రష్యా అనుకుందాం, ఇది ఇండియా అనుకుందాం. Normally each satellite will have certain transponders which will make use of certain frequency or bandwidth. So if US is not going to use it's 100% frequency or bandwidth. Some of the frequency is left out. That means the efficiency is not 100%. Similarly, Russia is also may not be using full 100% at any point of time. Similar with India. But if we make a inter-satellite link, then what can happen? Tomorrow, instead of these three countries sending another satellite, they can make use of other countries' left out frequencies, and they can make use of that for the future projects. So inter-satellite link and making them more efficient. That is one solution. Another solution, we are saying that formation of satellite clusters. So here what we will do is, we are going to place a satellite in geostationary orbit. But for that, we will link 4 more satellites in geosynchronous orbit. We are going to form a satellite cluster. Okay, single satellite, by connecting with 4 more satellites, we are going to increase the capacity of that single satellite. In a satellite clusters andam. Okay, so formation of satellite clusters. And మిగిలిన అన్ని మనకి ఏ ఆర్బిట్ లో ఉంటాయి? సింక్రోనస్ ఆర్బిట్ లో ఉంటాయి. మనకి సింక్రోనస్ ఆర్బిట్స్ అనే అన్లిమిటెడ్ ఉన్నాయి. జియోస్టేషనరీనే ఒకటే ఉంది. Okay, so one will be placed in geostationary and it will be linked with other satellites from geosynchronous orbits. And deorbiting the satellite once its lifespan is over. Okay, after 15 years, it should not stay in the geostationary orbit. It should deorbit. Deorbit and again either come back to the Earth. Or one more solution, use of graveyard orbit. Graveyard orbit and ఏంటి అనేది నెక్స్ట్ స్లైడ్ లో చూద్దాం. ఓకే, సో ఫస్ట్ ఇక్కడ ఏదన్నా మీకు ఆ డయాగ్రామ్స్ అదేమన్నా కావాలంటే డ్రా చేసుకోండి. ఐ విల్ గివ్ 1 or 2 minutes. What is a graveyard orbit? We will see. Any doubts still here? Or anything you are not able to understand? Use of non-geostationary communication satellite. Just place them in low Earth orbit. Satellite linking. See, by linking the satellites, we are going to make use of the left out frequencies of a particular satellite. Okay, a single satellite of a particular country may not be using the whole frequency. Let us say something like this has a frequency 15 gigahertz to something like 25 gigahertz frequency is allocated for this. It may not be using the full level of the frequency. If we link the satellites of 2 or 3 countries, we can make use of the left out frequency of other country. Okay. Next, as I have told you, last point, graveyard orbit. So graveyard orbit, normally what is a graveyard? శ్మశానం. ఏం చేస్తాం అక్కడ? Okay, we bury the dead bodies. So graveyard orbit is also a similar thing. Okay, there we will place the dead satellites. Each and every satellite will have some life cycle. It might be 10 years, 15 years, 20 years, up to 25 years. Okay, once the satellite lifespan is over or the objective of that satellite is over, that means it is a dead satellite. So instead of that dead satellite, okay, being in the stationary orbit, geostationary orbit, just like that, what we are going to do is, at the end of its lifespan, we will give a boost to that satellite so that it will go okay, let us say this is Earth and this is 35,786 kilometers. At the end of its lifespan, దీనికి కొంచెం బూస్ట్ ఇస్తే బియాండ్ 35,786 kilometers ఒక ఆర్బిట్ లో అది ఉంటుంది. అండ్ సచ్ ఆర్బిట్ వీ కాల్ ఇట్ యాజ్ ఏ గ్రేవ్యార్డ్ ఆర్బిట్. All the dead satellites at the end of their lifespan, what we will do? Simply we will send it to some other orbit and they will be revolving there. Okay, అలాంటి ఆర్బిట్ నేమ్ అన్నాం గ్రేవ్యార్డ్ ఆర్బిట్. Okay, so a graveyard orbit, also called as junk orbit or disposal orbit, is an orbit that lies away from the common operational orbits, like geostationary and geosynchronous orbit. These are operational orbits. So beyond the operational orbit, some inoperational orbit, దానిలోకి తీసుకెళ్ళి ఆ శాటిలైట్ వదిలేయడం. ఓకే, అండ్ వన్ సిగ్నిఫికెంట్ గ్రేవ్యార్డ్ ఆర్బిట్ ఇస్ ఏ సూపర్ సింక్రోనస్ orbit well beyond the geosynchronous orbit. So beyond the geosynchronous orbit, take the satellite and leave it there. Some satellites are moved into such orbits at the end of their operational life to reduce the probability of colliding with operational spacecraft and generating what we call as space debris. Now we will look at what is space debris, what are the issues with space debris, and how we are going to tackle this space debris. Okay, very important concept, space debris. Before that, ఈ క్వశ్చన్ రాసుకోండి. Yeah, that I will tell you. Inside the satellite there will be something called as booster. శాటిలైట్ లోపల ఒక చిన్న రాకెట్ ఉంటుంది అనమాట ప్రతి శాటిలైట్కి, ఇన్సైడ్ ద శాటిలైట్. సో అట్ ద ఎండ్ ఆఫ్ ఇట్స్ లైఫ్ స్పాన్ అండ్ ఈచ్ అండ్ ఎవ్రీ శాటిలైట్ విల్ హ్యావ్ సమ్ ఫ్యూయల్. ఆ ఫ్యూయల్ అనేది శాటిలైట్ ఆపరేషన్కి ఉపయోగపడదు, ఓన్లీ వెన్ వీ వాంట్ టు గివ్ ఇట్ సంథింగ్ కాల్డ్ బూస్టింగ్, దానికోసం ఉపయోగిస్తాం. ఇన్సైడ్ ద శాటిలైట్ ఒక చిన్న రాకెట్ ఉంటుంది, ఆ రాకెట్తో దానికి స్మాల్ బూస్ట్ ఇస్తాం సో దట్ ఇట్ విల్ గో టు దట్ ఆర్బిట్. నార్మల్ ఆపరేషన్ ఆఫ్ శాటిలైట్కి మనకి ఫ్యూయల్ అవసరం లేదు, దానికి ఏం కావాలి, జస్ట్ దాని వెలాసిటీ అండ్ ఎర్త్ గ్రావిటేషనల్ పుల్, దానివల్ల తిరుగుతూ ఉంటుంది. ఓన్లీ వెన్ వీ వాంట్ టు మాన్యూవర్ ద శాటిలైట్ అవుట్ ఆఫ్ ద పర్టికులర్ ఆర్బిట్ విల్ రిక్వైర్ బూస్టింగ్. దానికోసం ఇన్సైడ్ ద శాటిలైట్ ఒక స్మాల్ రాకెట్ సిస్టమ్ ఉంటుంది అన్నట్టు. ఓకే, నౌ ఫ్రమ్ ద ఎర్త్ విల్ ఆపరేట్. ఫ్రమ్ హియర్ వెన్ వీ గివ్ ఇన్స్ట్రక్షన్స్, okay, the satellite will change its path. Right. Good question. So again, how to write answer for this question? What you will write in the introduction? But that is already asked in the question. That introduction avadu. If I have not asked what is geostationary orbital crowding, then that can be an introduction. But I have already asked in the question, so you need to keep a heading geostationary orbital crowding and then define. So before that, what could be introduction? Yesterday I have told you, introduction lo em rayali, some current affair aspect related to this topic. So not current affair, simply can I write something like this? In the recent times, it is becoming difficult for the countries or telecom operators to place their satellites in the geostationary orbit. అట్లా ఏదైనా రాయొచ్చు కదా. ఆర్ ఏదైనా న్యూస్లో దానికి సంబంధించి న్యూస్ ఆర్టికల్ వస్తే వీ కెన్ మేక్ యూజ్ ఆఫ్ దట్. అదర్వైజ్ మేక్ ద ఇంట్రడక్షన్ సంథింగ్ లైక్ యు ఆర్ రైటింగ్ సమ్ కరెంట్ అఫేర్ ఆస్పెక్ట్, అలా ఉండేటట్టన్నా రాయాలి. ఒకవేళ లేకపోయినా రీసెంట్గా అదేదో జరిగింది అని అన్నా చెప్పాలి. ఓకే, దెన్ యూ విల్ కీప్ ద హెడింగ్ జియోస్టేషనరీ ఆర్బిటల్ క్రౌడింగ్ అండ్ యూ విల్ ఎక్స్ప్లెయిన్ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ దట్. ఓకే, అండ్ సమ్ ఆస్పెక్ట్స్ రిలేటెడ్ టు దట్, ఆ స్లైడ్లో ఏదైతే ఉందో అవన్నీ. దెన్ యూ విల్ కీప్ ద హెడింగ్ మెజర్స్ టు ట్యాకిల్ దిస్ గ్లోబల్ క్రైసిస్. ఏదైతే మనం 5-6 పాయింట్స్ ఇచ్చామో వాటిని హెడ్డింగ్స్ లాగా పెట్టుకోవాలి. అండ్ యూ షుడ్ ఎక్స్పాండ్ ఆర్ ఎక్స్ప్లెయిన్ ఈచ్ అండ్ ఎవ్రీ పాయింట్. ఇక్కడ మనం ఏదైతే పాయింట్స్ లాగా చెప్పానో యాజ్ ఇట్ ఈజ్ అవి రాస్తే ఆన్సర్ అవ్వదు, వాటిని హెడ్డింగ్స్గా వాడుకుని దాన్ని ఎక్స్ప్లెయిన్ చేసుకుంటూ వెళ్ళాలి. వీలైతే ఏదన్నా రీసెంట్ ఎగ్జాంపుల్స్ దానికి సంబంధించి ఉంటే ఆ ఎగ్జాంపుల్స్ కూడా ఇవ్వాలి, కరెంట్ అఫైర్ ఎగ్జాంపుల్స్. ఓకే, సో వెన్ ఐ సే టు attempt that question and write the answer, when you go home, search these topics in the news. Google search చేయండి, దానికి సంబంధించి ఏదైనా న్యూస్ ఆర్టికల్స్ కనిపిస్తే వాటిని చదవండి, అందులో ఉన్న పాయింట్స్ కొని మీ ఆన్సర్లో ఇన్కార్పొరేట్ చేయండి, నాట్ జస్ట్ ఆన్ ద స్లైడ్స్. ఓకే, యూ హ్యావ్ టు డూ ఏ లిటిల్ బిట్ ఆన్ యువర్ ఓన్. ఓకే, దెన్ ఓన్లీ ద ఆన్సర్ విల్ బి గుడ్. ఓన్లీ స్లైడ్స్ యూస్ చేస్తే ఏమైంది, స్టాటిక్ ఆన్సర్ అవుతుంది, విచ్ వోంట్ ఫెచ్ యూ మచ్ మార్క్స్. ఆల్ రైట్, always remember one thing, coaching is only 40% of your preparation. 60% of the preparation you have to do on your own. Coaching will just guide you what to read, what not to read, and you learn some basics here. You have to build on those basics. A foundation will be laid in the class. On that foundation, you have to build your building on your own. Okay, only 40% of the preparation is done in the class. 60% you have to do on your own once you go to your room. Okay. So next concept, space debris. So space debris means any kind of man-made object. Okay, any kind of man-made object that is revolving in the space. Okay, or just moving in the space, which don't have any utility. Okay, once again I will repeat, any kind of man-made object that is revolving in the space or moving in the space which don't have any kind of utility. అంటే అనవసరమైన man-made objects ఏదైతే మనకి స్పేస్ లో ఉంటాయో వాటిని స్పేస్ డెబ్రిస్ అంటాం. ఓకే, so most of the space debris comprises of human generated objects such as pieces of the spacecraft. So once we launch a launch vehicle, what I have told you, each of the part will come out, either it will evaporate or some of the pieces might be just revolving. Okay, danlo konni parts. Okay, that comes under space debris. So pieces of a spacecraft or tiny flecks of paint from the spacecraft or a satellite or parts of rockets or satellites that are no longer working or explosion of objects in orbit flying around in the space at high speeds. That means either a satellite has exploded or it has went and collided with another operational satellite. Because of that, whatever the junk is generated, that is what we call as space debris. Mainly space debris consist of human made objects, but along with human made objects, other things also can be there, like remnants of asteroids. Okay, asteroid dust or anything like that can also be called as space debris. Okay, so most space junk, okay, or space debris will be moving at very higher speeds. Okay, they will be moving very fast and can reach speeds up to 18,000 miles per hour, almost 7 times faster than a bullet. Now, when such a fast moving object, okay, goes and collide with a operational satellite, what will happen? ఒక ఫాస్ట్ మూవింగ్ ఆబ్జెక్ట్ వెళ్ళి ఒక ఆపరేషనల్ శాటిలైట్ ని ఢీ కొంటే ఏమైంది? దట్ ఆపరేషనల్ శాటిలైట్ విల్ ఆల్సో ఎక్స్ప్లోడ్. అంతేనా? అండ్ బికాస్ ఆఫ్ దట్ వాట్ విల్ హ్యాపన్? మోర్ స్పేస్ డెబ్రిస్ విల్ బి క్రియేటెడ్. ఓకే, ఒక స్మాల్ పీస్ ఆఫ్ జంగ్ వచ్చి ఒక ఆపరేషనల్ శాటిలైట్ కొలైడ్ అయింది, దానివల్ల ఇది ఎక్స్ప్లోడ్ అయింది. ఇప్పుడు ఇది మొత్తం మళ్ళీ స్పేస్ డెబ్రిసే కదా, ఇవన్నీ మళ్ళీ గాల్లో తిరుగుతూ ఉంటాయి, అవి వెళ్ళి ఇంకో దానికి కొలైడ్ అవ్వచ్చు. సో ఎట్ ద ఎండ్ ఆఫ్ ద డే సంథింగ్ కాల్డ్, ఓకే, ఒక క్యాస్కేడింగ్ సిండ్రోమ్ వల్ల ఏ హోల్ ఆర్బిట్ కెన్ ఆల్సో బికమ్ ఇన్ఆపరేషనల్. అవచ్చా లేదా? A object going and colliding with operational satellite, because of that more objects created, and those objects going and colliding with another operational satellite, and like this in a chain reaction a whole orbit can also become inoperational, and such a scenario is what we call as Kessler syndrome. చూద్దాం నెక్స్ట్ స్లైడ్ లో వస్తుంది. So it could land as one piece and more probably as many and scattered over an area up to several hundred miles. ఓకే, ఇది దేని గురించి చెప్తున్నాం? ఏదైతే వెళ్ళి ఒక మూవింగ్ ఆబ్జెక్ట్ వెళ్ళి ఒక ఆపరేషనల్ శాటిలైట్ ఢీ కొంటే దానివల్ల వచ్చే మనకి డెబ్రిస్ ఏదైతే ఉంటుందో, ఇట్ కెన్ బి వన్ పీస్ ఆర్ మోర్ ప్రాబబ్లీ స్కాటర్డ్ ఓవర్ several hundred miles. Now Kessler syndrome. Okay, according to the Kessler syndrome, if there is too much space junk in a particular orbit, what can happen? It could cause a chain reaction where more and more objects will collide and produce new space junk, and in the process until Earth's orbit is rendered useless in a domino effect. Dominoes అంటే ఐడియా ఉండుంటుంది కదా, ఇలా ఉంటాయి, ఒకదానిపైన ఒకటి పడితే ఫైనల్గా అన్నీ పడిపోతాయి. సో ఒకటి పడటం వల్ల మొత్తం పడతాయి. సో జస్ట్ లైక్ దట్, in a domino effect a whole orbit can become inoperational. దీన్నే కెస్లర్ సిండ్రోమ్ అంటాం. Yes, spacecraft and anything that is going into space. It can be a launch vehicle or it can be a satellite as well. Satellite and the thing that is revolving or orbiting the Earth. Spacecraft can be launch vehicle or a satellite. Normally, ఇప్పుడు like not always in a launch vehicle we send satellite. Sometimes we can send something like lander that we have sent for Chandrayaan. అదే ఆస్ట్రోనాట్స్ తీసుకెళ్లే ఆర్బిటాల్ మాడ్యూల్ అవ్వచ్చు, ఏదైనా మనకి స్పేస్ క్రాఫ్ట్, సంథింగ్ దట్ ఈస్ గోయింగ్ ఇన్ టు స్పేస్. ఏంటేమైంది? International events or agreements related to the space junk. Now there is space junk, but are there any international agreements or some conventions how to deal with this space junk? Okay, so we have one agreement called Space Liability Convention 1972. But the Space Liability Convention, it talks only about liability when a space junk falls on some other country. That means, let us take one example. There is a space junk of China which has recently fallen, okay, in a village in Maharashtra in India. Okay, so when such thing happens, the space junk which has originated from the country will be liable to pay some kind of compensation where it has fallen. ఓకే, ఇండియాలో పడింది కాబట్టి ఇండియాకి కొంత చైనా కాంపెన్సేషన్ అనేది పే చేయాలి. సో ఎలా కాంపెన్సేషన్ పే చేయాలి, దానికి సంబంధించిన రూల్స్ అండ్ రెగ్యులేషన్స్ ఆర్ గివెన్ ఇన్ దిస్ స్పేస్ లయబిలిటీ కన్వెన్షన్ ఆఫ్ 1972. బట్ ద ప్రాబ్లమ్ విత్ దిస్ కన్వెన్షన్ ఈస్, okay, it is saying only when there is some harm that happens, a liability has to be paid. One more problem here. Recently I told you some piece of junk from China has fallen in India. China will simply say that దానికి మాకు ఎటువంటి సంబంధం లేదు, వీఆర్ నాట్ రెస్పాన్సిబుల్, అది అక్కడి నుంచి వచ్చిందో మాకు తెలియదు. ఓకే, దే కెన్ సే సంథింగ్ లైక్ దట్. అండ్ యాజ్ ఆఫ్ నౌ, ఓకే, దిస్ కన్వెన్షన్ కేమ్ ఇన్ 1972. టిల్ టుడే only one settlement happened under this convention, that too way back. The only settlement using liability convention was between erstwhile Soviet Union and Canada over a debris of Soviet cosmos falling in a barren region in Canada. But after that many incidents happened, but always the country from which that space junk has originated will say that we don't have any knowledge of that space junk. Okay, so it defines the responsibility in case of space object causes harm. So one drawback or limitation of this convention is, it is saying only when the object causes harm. Otherwise, there is no liability. Okay, so absence of a proper law at the international level to deal with space debris as of now. So however, there is no law against space junk crashing back to the earth, and should the debris hit something or over someone, people affected will be liable for compensation. Otherwise, okay, nobody is going to. Otherwise, there is no international rule to prevent or restrict uncontrollable re-entries. Only when it causes damage for a particular person or for a particular property, then only liability is defined. Otherwise, just for uncontrolled re-entries, there is no international law or international convention, okay, which is looking after them. So there is absence of law to deal with space debris as of now. And recent incident, as I have told, okay, suspected debris from a Chinese rocket was found in Maharashtra village, but simply China has claimed that we don't have any knowledge about that. Now what are the other international measures to deal with space debris? Okay, so how are the international community want to deal with this space debris which is a potential threat to our operational satellites? Ante kada, operational satellites ki potential threat. And right now what is happening is, many a times a space debris might be coming very close to our operational satellite. So our operational satellite, what they do is, to avoid that space debris, they will do something called collision avoidance maneuver. I have told you just now, there will be a inbuilt rocket inside the satellite. By using that inbuilt rocket, what we do is, let us say this is orbit and this is a satellite. A space debris is coming in its way. The satellite will just move away from the line of space debris so that it will pass away and again will come back to its place. This is what we call as collision avoidance maneuver. And right now each and every country is doing such collision avoidance maneuver, and just in 2020 India has done almost 14 to 15 such collision avoidance maneuvers, okay, to move away from the space debris. So unless we deal with the problem of space debris, okay, tomorrow Kessler syndrome like thing can happen as well. Okay, so first and foremost important mission dealing with the space debris is remove the debris mission. Okay, so the goal of this satellite or research project was to showcase different space debris removal techniques, different kinds of techniques that we can employ in the future to remove the debris already present in the space. Okay, remember, this is not going to remove, this is just to demonstrate or test the technologies that can be employed in the future to remove the debris. Okay, the mission was overseen by Surrey Space Center from the University of Surrey and Surrey Satellite Technology Limited produced the satellite platform. Now, how this remove the debris mission works, what are the technologies associated with it, we'll see. So basically, we have different technologies that we are testing under this remove the debris mission called net capture, harpoon capture, vision based navigation, deorbiting process and laser broom. First, I will briefly explain you all these concepts. Then we will look at a video how all these things work. Okay. So net capture, as the name suggests, here what we will do is we will send a satellite into space, and from that satellite ఒక నెట్ వేయటం జరుగుతుంది, ఒక వల. Okay, by using a net we will capture the space debris and we will again bring it back to the earth. That is one method. Second method, harpoon capture. Again, that satellite that is launched, okay, from that satellite a plate will come out, a electromagnetic plate, and to that electromagnetic plate the space debris will come and attach. ఎందుకు మనకు స్పేస్ డెబ్రిస్ లో మనకి మ్యాగ్నెటిక్ పార్టికల్స్ ఉంటాయి కాబట్టి వచ్చి దానికి అటాచ్ అవుతుంది, దెన్ వీ విల్ అగైన్ రిమూవ్ ఇట్. దట్ ఈస్ సెకండ్ మెథడ్. విజన్ బేస్డ్ నావిగేషన్. సో ఫర్ దిస్ శాటిలైట్, ఓకే, టు మూవ్, ఇప్పుడు డెబ్రిస్ లోపలికి దగ్గరికి పంపిస్తున్నాం కాబట్టి శాటిలైట్ కూడా తను ప్రొటెక్ట్ చేసుకోవడానికి ఇట్ విల్ యూజ్ అ స్పెషల్ టెక్నాలజీ కాల్డ్ లిడార్ టెక్నాలజీ. అగైన్ దిస్ లిడార్ టెక్నాలజీ విల్ డిస్కస్ వైల్ డిస్కసింగ్ లేజర్స్. రిమెంబర్ దిస్. Okay, it will send data about debris back to the ground for processing using cameras. So while the satellite is moving in the space, by using this lidar technology, okay, satellite నుంచి కొన్ని లేజర్స్ వస్తూ ఉంటాయి. ఆ లేజర్స్ వస్తూ ఉన్నప్పుడు దాని చుట్టుపక్కల ఏం డెబ్రిస్ ఉంది అనేది డిటెక్ట్ చేస్తుంది. ఆ డిటెక్ట్ చేసి గ్రౌండ్ స్టేషన్కి ఇన్ఫర్మేషన్ పంపిస్తుంది. గ్రౌండ్ స్టేషన్ immediately will tell the satellite, okay, at this particular location debris is there, go and capture that. Okay, vision based navigation will be used by the satellite. And another, deorbiting process. While deorbiting, okay, ఇప్పుడు ఏదైతే డెబ్రిస్ రిమూవ్ చేయడానికి పంపించామో అది మళ్ళీ డెబ్రిస్ అవ్వకూడదు కదా. సో వైల్ deorbiting the whole satellite will burn up in the atmosphere. Okay, the spacecraft after entering the Earth's atmosphere during the deorbiting process will burn up, leaving no debris behind. And one more, laser broom technology. A ground based laser beam will be used to sweep the space debris out of the path of satellite. ఒక గ్రౌండ్ నుంచి ఒక లేజర్ బీమ్ అనేది బ్రూమ్ లాంటిది యూజ్ చేసి ఆ శాటిలైట్ ముందున్న డెబ్రిస్ ని రిమూవ్ చేయటం. ఆల్ దీస్ టెక్నాలజీస్ వీఆర్ టెస్టింగ్ ఇన్ దిస్ రిమూవ్ ద డెబ్రిస్ మిషన్. జస్ట్ వీఆర్ టెస్టింగ్. యాజ్ ఆఫ్ నౌ వీ డోంట్ నో వెదర్ దే విల్ వర్క్ ఆర్ నాట్. ఓకే, లెట్స్ సీ how అదంతా స్పేస్ డెబ్రిస్. యానిమేషన్ కింద సబ్ టైటిల్స్ వస్తుంటాయి చూడండి. Experiment 1, net capture. Vision based navigation. So simply it is sending the data to a ground based center. Harpoon capture, a plate and something coming and getting attached to it. Now the laser broom will be tested. See. Just clearing out the path of the satellite by using a laser. And finally deorbiting, the whole satellite disappears. So most important mission related to space debris handling, remove the debris mission. Okay. So under that mainly what we are doing, the main aim is at performing key active debris removal technology demonstrations. Okay, we are only demonstrating the technologies that we might deploy in the future. Okay, only demonstration of the technologies. And the mission will comprise of a main, okay, anta manaku avasaram ledu, video lo chupichinattu. So just remember these names: net capture, harpoon capture, vision based navigation, deorbiting process, and laser broom. So first one we have seen remove the debris mission in the international measure. Second one, Kunotari experiment. This is by the Japan. Okay, it is a Japanese experiment using a innovative technique to remove the space debris that is orbiting around the Earth. And Japan is also trying to manufacture their satellites by using wood instead of metal. Okay, it is actually testing for something like if we can make satellites by using wood. So at the end of their lifespan, simply what can happen? While deorbiting, they will just burn up without leaving any kind of space debris. Okay, as of now it is not there. They are just testing such kind of technologies. This is different Kunotari experiment, but another experiment that is done by Japan. So one experiment, Kunotari experiment, Japan is also doing something related to space debris. Now what India is doing related to this? So in India we have something called Project Netra. Okay, so this Project Netra is not actually a remove the debris mission or anything like that. This is a mission or this is a project under which what we are going to do is we are going to track the space objects. Now, if you want to do something like collision avoidance maneuver that I have explained, for doing that, first we need to identify that a space debris is going to come in contact with our operational satellite. For that, what we need to do? We need to have some understanding about the space. Okay, we need to observe the space and we need to know what is happening in the space. For that, we are going to use our project called Project Netra. Okay, and this concept is what we call as space situational awareness. Okay, what is the situation right now in the space? Where are the space debris? In which direction they are moving? Or with that space debris, is there any chance of coming them and colliding with our operational satellites? This is what is called as space situational awareness. Right now, India has the capability of this space situational awareness till the low Earth orbit only. Okay, but other countries like NASA and Russia, they have the capability till geostationary or geosynchronous orbit. So if at all any space debris is going to be in contact with our geostationary or geosynchronous satellite, then NASA or Russia will warn us, okay, beforehand, so that we can do our collision avoidance maneuver. Okay. So Project Netra is a early warning system in the space to detect the debris and other hazards to the Indian satellites. So once operational, it will give India its own capability in space situational awareness like the other space powers. And what is the need with countries launching more and more satellites, each one of them being a strategic or commercial asset, avoiding collisions could become a challenge in the future. And for protecting our space assets, in 2021 alone, ISRO has done 19 collision avoidance maneuvers. Okay, what I have explained. If some space debris is going to come in contact with our operational satellite, we will first move our satellite, okay, so that will pass away, that space debris will pass away, and again we will keep it in the orbit. Okay, దీన్నే collision avoidance maneuvers అంటాం. For doing that as well, first we need to track the space debris. For tracking the space debris, we have the project called Project Netra. Okay, but the problem here is right now the capability of Project Netra is only till the low Earth orbit. Over a period of time, we want to increase its capacity to geostationary and geosynchronous orbits as well. Now, one more advantage of this Project Netra is going to be, because by using this, we are going to mainly observe the low Earth orbit. That is from 180 kilometers to around 2000 kilometers. Now, ballistic missiles, later we will see in the defense technology, ballistic missiles, what they do is, they go beyond the space, they will enter into low Earth orbit and then they will hit the target on the Earth. Now, using this Project Netra, we can also track the ballistic missiles coming from other countries as well. One more advantage of Project Netra. Okay. So modus operandi under Netra, ISRO plans to put up many observation facilities like connected radars, telescopes, data processing units, etc. simply for observing the space. And benefits, Netra can spot or track and catalog the objects as small as 10 centimeter up to a range of 3400 kilometer, in altitude terms up to 2000 kilometers. Range is different from altitude. Okay, this is range, this is altitude. Okay, altitude up to 2000 kilometer, that is till the low Earth orbit. And Netra effort would make India a part of international effort towards tracking and warning about and mitigating the space debris. And more importantly, it has a military quotient as well, because it can track other kinds of objects like aircrafts, missiles, etc., drones and all those things as well. And it is a vital requirement for protecting our space assets and acts as a force multiplier, mainly for collision avoidance maneuver. If you want to do collision avoidance maneuver, first we need to know the threats that are emanating for our satellites. Okay.